We're not going to worry about letter S here because we always write Lewis structures to determine the molecular geometry. So for example, if we have ICl3, I would draw the Lewis structure. Cl's in group 7. And iodine is also in group 7. So when you draw the Lewis structure, you'll see that the central atom has 2 lone pairs. So the type is AB3E2, and that forms a teeth-shaped molecular geometry, bond angle of 90. In H2, the electron pair is shared equally because there's not a difference in electronegativities between the hydrogen atoms. But in the hydrogen chloride molecule, chlorine has a larger electronegativity than hydrogen. This causes the electron pair to be drawn closer to the chlorine. So in this molecule, the shared pair of electrons right here is more attracted to Cl because of the higher electronegativity. Covalent bonds in which electron pairs are shared unequally are referred to as polar covalent bonds, like HCl. Anytime you have 2 different nonmetals bonded together, it will be a polar covalent bond. Nonpolar covalent bonds are bonds in which electron pairs are shared equally. This only happens if it's the same atom bonded to itself, like H2, Cl2, and so forth. The hydrogen end of the HCl molecule is positive with respect to the chlorine end. So chlorine becomes slightly negative, higher electronegativity, hydrogen becomes slightly positive. Another way to denote this would be like this, with the positive end being the hydrogen and the arrow pointing toward the negative end of the molecule. So there are 3 types of bonds essentially: nonpolar covalent bonds, polar covalent bonds, and ionic bonds, which occur between a metal and a nonmetal. Bond polarity is sometimes expressed as partial ionic character, which increases with increasing difference in electronegativity. Molecules with 2 charge centers are called dipoles. For example, HCl molecule is a dipole. There's a negative end and there's a positive end on this molecule. The percent ionic character for HCl is 16%. Pauling, who developed the electronegativity scale, said that if the difference in electronegativity between 2 atoms is 1.8 or greater, the bond is ionic. If it's less than 1.8, it's covalent. So for HCl, the difference between the hydrogen and chlorine electronegativity is 0.9, which means it's a covalent bond. Molecular shapes and dipole moments. Let's look at this molecule, BeCl2. It's a linear molecule. Chlorine is slightly negative, higher electronegativity. Beryllium is slightly positive. Since it's linear, the bond angle is 180. Now the bonds are polar. There's a slightly negative, slightly positive on the bonds. However, the bond dipoles are identical in magnitude but opposite in direction. So the molecule is nonpolar. It has polar bonds, but the molecule itself is nonpolar. Water, on the other hand, has polar bonds as well. The oxygen is slightly negative, while the hydrogen are slightly positive, but the bond angle is 104 instead of 180. It's not a linear molecule. So the molecule is polar because these dipoles do not cancel out. The easiest way to tell whether a molecule is polar or not, look for lone pairs around the central atom. If there are no lone pairs, the molecule is nonpolar. If there are lone pairs on the central atom, it's going to be polar with 2 exceptions, AB2E3 and AB4E2. So when looking at molecules, draw the structure, NH3, determine whether the central atom has lone pairs. NH3 does. This type is AB3E. It's not one of the exceptions, so this molecule is polar. PCl5. Without drawing all the electrons around the Cl, phosphorus has 5. And you'll see that around the central atom, no lone pairs. So this molecule is non-polar.